In this video, we're going to cover integration by substitution, or U substitution. So we have found that you evaluate an integral by finding the antiderivative. This becomes more difficult if the function we are integrating is the result of using the chain rule. Well, U substitution is a way of undoing the chain rule. It's a method of integration that can turn a complicated integral into an easy integral to evaluate. So if you have some integral f of g of x times g prime of x dx, we can turn this into this nice simple integral of f of u du, by letting u equal the inside function g of x. That means we're taking the derivative of u, which is just g prime of x dx. So we've got to find the u. The u is the inside function. Start by looking in the parentheses, in your exponents, maybe the denominator. So once you find that inside function, you'll take the derivative of it. You'll solve for dx, and we'll make some substitutions, and then finish it out. So let's take a look at some examples. Here's your first one, and this is on page 1 in your Cycle 3 packet. So we can see we've got parentheses. So I'm going to jump right to the inside function and label that u is equal to x plus 3. Well, we know that du dx, the derivative of this function would just be 1. And so in this case, dx is equal to du if I multiply both sides by dx to get it out of the denominator. All right, so now that we have that, let's go ahead and make some substitutions. So what I've got is the integral of u to the 5th, and then dx is now du. Now this is pretty simple to evaluate. This is just u to the 6 over 6 plus c, since we have an indefinite integral. Let's make a substitution for u. And so u is x plus 3, and so this is just going to be u plus 3 to the 6 over 6 plus c. And this is my final answer. That wasn't so bad. Here's another example in your Cycle 3 packet. Right away I see I've got an inside function here, so let's go ahead and call that my u. Let's take the derivative of it and then solve for dx. If I were to multiply both sides by dx and then multiply both sides by 1/3, I'll have 1/3 du. So we make our substitutions. This is the integral of u to the 4th and times 1/3 du. All of our variables are u's, so this is good. I'm going to go ahead and move that 1/3 out front, and then this is a pretty simple integral to evaluate. This is 1/3 u to the 5th over 5 plus c, and this is going to be well, u to the 5th over 15 plus c, and then I'll make that substitution for u. U was 3x minus 4, so this is going to be 3x minus 4 all to the 5th over 15 plus c, and that's my final answer. In example 2, I've got a denominator, so I'm going to go ahead and call that my u. And so 4x plus 1, that means du dx is equal to 4, and so dx is going to be, if I isolate the dx, I'm going to have 1/4 du. All right, let's make our substitutions. This is going to be the integral of 5 times 1 over u, and then dx is now 1/4 du. I can combine the 5 and the 1/4 and bring it out front. So this is going to be 5/4, the integral of 1 over u du. And we should recognize that is the natural log. All right, we make a substitution for u, and this is going to be 5/4 natural log of 4x plus 1 plus c, and that's my final answer. I'm just checking my answers, making sure we have everything right. Yep, we're good. Okay, here's another one. This time we have some parentheses, so I'm going to start with that. I'm going to let my u equal to 4x squared. That means du dx is going to be 8x, and if I solve for dx, that's going to be 1 over 8x du. All right, so we make our substitutions. I have the integral of x times cosine u, and then dx is 1 over 8x du. Now, in the previous page, I said all your variables have to be the same. Well, I've got x's and u's, but in this case, my x's canceled, so that's a good thing. I'm going to move that 1/8 out front, and I just have now the integral of cosine u du. And that's pretty easy to evaluate. And so that's going to give me, well, let's see, 1/8 derivative of sine is cosine, so this is going to be sine u plus c. And then we make our substitution for u. 1/8 sine of 4x squared plus c. Okay, try these. On page 3 in your cycle 3 packet, pause the video and go ahead and work it out and then compare your answers. In this problem, I see I have a denominator, so I'm going to pick my u as 1 minus 2x. So du dx, the derivative of this would just be negative 2. And if I solve for dx, that's going to give me, well, negative 1 over 2 du. Make some substitutions, so I've got 1 over u times negative 1/2 du. Bring the 1/2 out front, and there's 1 over u du, and this is going to give me negative 1 over 2 natural log of u plus c. And then I make my last substitution, natural log of 1 minus 2x plus c. And we're doing good. All right, here's a couple more. In number 2, I'm going to go ahead and let my u be 5x squared minus 1. That means my du dx is 10x. If I solve for dx, that's going to give me 1 over 10x du. Now I make my two substitutions. I have the integral of x times u to the 7th times 1 over 10x du. Again, I've got two different variables, but the x will cancel, and I've got a pretty simple problem to solve. I can bring the 1/10 out front, u to the 7th du, and so this is going to give me 1 over 10 u to the 8th over 8 plus c. Go ahead and combine the fractions and make the substitution for u, and I've got 1 over 80 and times 5x squared minus 1 to the 8th plus c. Alrighty, in number 3, I've got an inside function and I've got an exponent. So I have two different possible u's. Let's go ahead and let's let u equal 4x, and let's see where that takes us. If I let my u equal 4x, that means du dx is going to equal, well, 4. And dx is going to equal 1/4 du. If I make my substitution, so that's going to be e to the sine u cosine u times 1/4 du. Yeah, I have not simplified anything. I'm still unable to find the antiderivative of this. So what this means is we have to erase and pick a different u. All right, so this time let's pick u as sine 4x. Let's see where that takes us. All right, and so u is equal to sine 4x. All right, so if I take the derivative du dx, this is going to give me, well, let's see, the derivative of sine is cosine 4x, and the derivative of the inside function is 4. Okay, so we're going to solve for dx. So dx is equal to 1 over cosine 4x times 4 du. When I make the substitutions, this time I have the integral of e to the sine u, nope, I'm sorry, whoops, e to the u, because sine 4x is my u, and then this is going to be times cosine 4x, make the substitution for dx, so this is times 1 over cosine 4x times 4 du. Now I've picked the right u because my cosine 4x's are canceling. I can bring that 1/4 to the front, and look how pretty this is. Now this we can integrate. All right, well, the antiderivative of e to the u is e to the u, so that's just e to the u plus c. Make our substitution for u, so 1/4 e to the u was sine 4x plus c, and that's my final answer. Okay, here's one that I've already worked out. I let u be the 3x squared minus 2, what's under the radical here, and then so the derivative is 6x, and if I solve for dx, I have 1 over 6x du. When I make that substitution, I see that my x's cancel, so I'm in good shape. 3 over 6 is 1/2, and I move that out front. I rewrote the square root as u to the negative half, and I brought it out of the denominator. And then find the antiderivative of this, add 1, so that's 1/2 over 1/2. And when I multiply 1/2 by the reciprocal of 1/2, that gives me 1, and so I'm just left with the square root of u plus c. All right, so now let's evaluate. This puts some boundaries on this, and this is on page 4 in your Cycle 3 packet. And so let me find my notes real quick. Okay, so I'm going to go ahead and let my u be 3x. That's my inside function. So du dx is equal to 3, and then dx is equal to, well, 1/3 du. Okay, so let's go ahead and write our integral. So this is going to be our integral of sine u and then times 1/3 du. Okay, so I left off the boundaries because the boundaries are in terms of x. Now we're working with u. So there's actually 2 ways we can work this. We can, well, I'm going to find the antiderivative, and then we can either change our boundaries to u boundaries, or I can sub back in the 3x and then use these boundaries, which are in terms of x. And I'll show you what I mean. All right, so let's keep working this one. All right, so I'm going to go ahead and bring the 1/3 out front, sine u du. I'm going to differentiate, so 1/3, and let's see, that's going to give me a negative cosine, I believe. So I'm going to bring that negative sign up front, cosine, and then this is u. And I'm going to, well, sub in the u again, and so this is going to give me negative 1/3 cosine of 3x. And this is evaluated at these x boundaries, 3 pi over 4 and pi over 4. And so if I just do some calculations here, cosine of 3 times, well, 3 pi over 4 minus cosine of 3 times pi over 4. And let's see, 9 pi over 4. I've got to draw myself a little unit circle. Well, 8 pi over 4 would be 2 pi. So 9 pi over 4 is in quadrant 1, and I know that my cosine value is square root 2 over 2. And so this is going to give me negative 1/3 square root 2 over 2. And now here, the cosine value at 3 pi over 4, 3 pi over 4 is in second quadrant, and I know that my cosine value is a negative square root 2 over 2. So this is going to give me a minus negative square root 2 over 2. And so this is going to give me, well, negative 1/3, and this is 2 roots 2 over 2, or root 2, which is just, I guess I could clean this up, negative root 2 over 3. Okay, so if I were to have changed my boundaries to u boundaries, I know that this is the equation to change. So if I have an x boundary of 3 pi over 4, that would be 3 times 3 pi over 4. And so my u boundary would be 9 pi over 4. That's my upper boundary. Now to find the lower boundary, I'll plug in the lower x boundary. So that's 3 times pi over 4, which is just 3 pi over 4. And so these would be my u boundaries, and I could have just solved it from here. And so let me show you what that looks like. So that would be negative 1/3 cosine u evaluated from 9 pi over 4 to 3 pi over 4. I personally like this method better, changing to u boundaries, because it's usually simpler. So let's see, this would be negative 1/3 and then cosine of 9 pi over 4 minus cosine of 3 pi over 4. And this is negative 1/3, and we already know that this is going to be square root 2 over 2 minus a negative square root 2 over 2. And it gives us the same answer, negative 1/3 square root of 2, which is, or negative root 2 over 3. All right, we'll practice this again. All right, here's another problem. Page 4 in your cycle, 3 packet. So I'm going to say my u is the inside function, 2x minus 1. That means du dx is going to give me 2. That means dx is equal to 1/2 du. All right, and so my integral of u cubed times 1/2 du. And so that's going to be 1/2 the integral of u cubed du, which is 1/2 u to the 4th over 4. And I'm going to go ahead and evaluate this with u boundaries. So I'm going to take my little equation for my u. And so if I have an upper boundary of 2, and that's an x, so that's 2 times 2 minus 1, this gives me 3. That means my upper u boundary will be 3. And then my lower u boundary, 2 times 1 minus 1, well, that's just 1. And so my lower u boundary is just 1. And so I can come over here, and I've got u to the 4th over 8 evaluated from 3 to 1. Okay, so 3 to the 4th is 81 over 8. And then minus, let's evaluate at the lower boundary, that's just going to be 1 to the 4th over 8, so 1 over 8. And so that just gives me 80 over 8, which is just 10. And that's done. If you work it out with the x boundaries, you just have to make the substitution for 2x minus 1 back in, and then evaluate it. Same answer. All right, so this one, it says you try, and it's not in your book. So if you want to pause the video, write this one down, and then check your answer again. I'm going to go ahead and pick for my u 2x cubed. That's in my exponent, and it could be wrong, but I'm going to try that. So du dx is equal to 6x squared. So that means dx is equal to 1 over 6x squared du. That looks good because I know I'm going to have this x squared cancel with this x squared. All right, so back to my problem. So I'm going to have the integral of, let's see, x squared e to the u times 1 over 6x squared du. These x's aren't bothering me because I know they're going to cancel right there and right there. I'm going to bring that 1/6 out front, the integral of e to the u du, and well, that's just e to the u, right? And I'm going to go ahead and change my boundaries to u using my equation. So u is equal to 2 times 1 cubed, which is just 2, and u is equal to 2 times 0 cubed, which is just 0. So my u boundaries are 2 and 0. Occasionally on a multiple choice test, your answers are going to be in terms of u, so you'll need to change your boundaries in terms of u. All right, so back to my problem here. I'm going to evaluate, let's see, 1/6e squared minus e to the 0. And so let's see, that's just going to give me 1/6. Well, e to the 0 is 1. So e squared minus 1/6. Let me just verify that answer. Some of these always look strange, so I just want to make sure I'm doing it. Yep, that's your answer. We're done. Okay, try another one. Actually, I think we're going to go ahead and do this one together. Let's rewrite this one as the integral of 1 over 1 plus 2x squared. Now, why would I do that? Does anyone recognize that we have the inverse of tangent right here going on? Because if I let my u equal 2x, du dx is equal to 2, so dx is equal to 1/2 du. So this is the integral of 1 over 1 plus u squared, and that is the antiderivative of that is inverse tangent, or arctangent, times 1/2 du. And so bring the 1/2 out front. This is going to equal, well, 1/2 inverse tangent of u, and I'll go ahead and substitute in the 2x. I'm not having to evaluate this one, so I'm not worrying about changing boundaries or anything, but I do need to add the c because it is an indefinite integral. Okay, let's try another one. Natural log x over x. Well, I'm going to go ahead and let u equal to natural log x. I could be wrong, but let's see what happens. So du dx is equal to 1 over x. So then dx is equal to, well, let's see, if I multiply both sides, it's going to be x du, which works out nicely because I know this x is going to cancel with this x. So we've picked the right u. Okay, so let's finish this up. So let's see, I'm going to have u over x times x du. X's will cancel, and then I'm going to end up with, well, whoops, sorry about that, the integral of u du. Well, that's pretty easy to differentiate. That's just u squared over 2 plus c, and then we'll make that substitution back in. So it's natural log of x squared over 2 plus c, and that one's done. All right, here's another one. Let's go ahead and rewrite this one as well, because I'm feeling like this is an inverse sine problem. And so if I rewrite this as the integral of x over square root of 1 minus, and then this is going to be x squared squared dx. So then I'm going to let my u equal to x squared. Du dx is equal to 2x, which is nice because I'm going to end up with an x in the denominator, which will cancel with this guy in the numerator. All right, so then dx is equal to 1 over 2x du. All right, so then I'm going to have, let's see, x over square root of 1 minus u squared times 1 over 2x du. The x's cancel, like we said, and we'll bring that 1/2 out front. 1 over the square root of 1 minus u squared du. We recognize this, hopefully, as inverse sine, and so this is 1/2 inverse sine of u, and I'll go ahead and make that substitution, so x squared plus c, because it's an indefinite integral. Okay, here's another one. What are we going to pick for our u? I'm going to go ahead and let u equal sine x. All right, and so du dx is equal to, well, cosine x. If I solve for dx, I end up with 1 over cosine x du. And look, that will cancel with this. That's what we want. All right, and so then my integral of sine x, and I'm going to rewrite this squared, cosine x dx. Now, let's go ahead and make our substitution. Since we let our u equal to sine x, this is going to be u squared cosine x, and then the dx is 1 over cosine x du. See how nicely this is working out? My cosines are canceling. I've got the integral of u squared du, which is easy peasy, u cubed over 3 plus c, and this is going to be, well, make that substitution for u, sine x cubed over 3 plus c. And let's see, one last example. Let's go ahead and let u equal sine 5x. We're going to make that whole exponent be the u. So du dx is equal to, well, let's see, the derivative of sine is cosine 5x times the inside function, which is 5. So dx is equal to 1 over cosine 5x times 5 du. And how nice, this is all going to cancel with this stuff in the numerator. All right, so I'm going to have the integral of cosine 5x over e to the u times 1 over cosine 5x times 5 du. Cancel in all of the cosine 5x. I'll bring the 1/5 out front. E to the negative u du. And I'm not done, because now I still have an inside function. In this problem, we're going to have to do a second round of u substitution. So I've already used u, so I can't use u again. Let's use t. So this will be our new variable when we have to do a second u sub. So I'm going to let my t be negative u. So dt du is equal to negative 1. So du is equal to negative dt. All right, so I've got 1/5 the integral of e to the t times negative dt. All right, so I'm going to bring the negative out front. So this is negative 1/5 integral of e to the t dt. Now this isn't too bad because the antiderivative of e to the t is just e to the t. And so this is going to give me, well, negative 1/5. And I can make a substitution for the t, which is negative u, and plus c, because we have an indefinite integral. Oh, hold up. I still need to make a substitution for the u. Last step, guys. Negative 1/5 e to the negative sine 5x plus c. I almost missed that, but thankfully I caught it.